Hello everyone, it is time for us to start talking about topic 7, and we're going to start that today with worksheet 7-1, which is all about dilations. Starting with number 10, Kendall was asked to find the scale factor of the dilation. What is Kendall's error? So she used 6 divided by 2, and it's 3, and she said, all right, the scale factor is 3. However, when she did her scale factor, she used 2 sides of the same rectangle. What she should have done is used one side of one of the rectangles and the corresponding side of another rectangle to find the scale factor. So we can say she used, oops, let me turn on my pencil. That's a weird phrase. She used 2 sides of the same rectangle. She should have used the new side over the corresponding old side. So in this case, we could use 3/6, and that would be 1/2. So the scale factor should be 1/2 or 0.5 there. Number 13, rectangle J prime, K prime, L prime, M prime is a dilation of JKLM with scale factor K. What are the perimeter and area of JKLM? So it is important to recognize that what you are given is the new shape and not the old shape JKLM. So when we use that scale factor on the old shape, we would multiply everything by K to get the new shape. Since we have the new shape, we're going to need to divide everything by K to get the old shape. So to find the perimeter of JKLM, I find the perimeter equation, which in this case is going to be 2 of each side. So 2A plus 2B, so that's the perimeter of the new shape. To turn it into the perimeter of the old shape, I need to say divided by, divided by K, the scale factor. So if I go backwards, I have to divide by the scale factor. For the area, I say, well, I would take the area by doing the length and width. If I was doing the length of the old shape, that would be A divided by K. If I was doing the width of the old shape, that would be B divided by K, since those scale factors make those sides that many times longer. And A over K times B over K will give me AB over K squared. So AB over K squared is the expression that represents the area of JKLM. Number 14, Carolina says that when a figure is dilated using a scale factor of 2, the angle measures in the image are twice the angle measures in the pre-image. How can you use the triangle angle sum theorem to explain why this cannot be true? Well, the triangle angle sum theorem is the one that says that the sum of the angles in a triangle is 180 degrees. So, of course, if we doubled them, it would be 360 degrees, which means that it wouldn't be a triangle anymore. So that would not be a dilation. So we can say she is incorrect. She is incorrect because the angles in a triangle add to 180 degrees. If you doubled them, it would be 360 degrees, which would not be a triangle anymore. Which would not be a triangle anymore. All right. Number 15, is it always true that a dilation of scale factor M combined with a dilation of scale factor N is equal to a dilation of a scale factor M times N? And explain. So let's explain this piece by piece because it is true. So we can say yes, because if I do a dilation with a scale factor of m on object x, I'm going to get m times length x. And if I do a dilation with scale factor n on x, I get n times x. And if I do both, and a dilation of m times a dilation of n of object x, I will get mn x the same way. So in the same way, if I do a dilation of scale factor mn, again, I'm multiplying both those things by object x, and I get m and x. So showing that that scale factor is really just going to multiply the side lengths. So if I do two of the scale factors at the same time, I'm just multiplying the side lengths by both of those numbers. Number 18, what is the scale factor of the dilation shown? I think I used the bottom here because it's a straight line. That was easiest for me to see. So point A to point P, that's 12 units. But then if I count point C to point 8 prime to point P, that's only 8 units. So I can say that my new distance from A prime to P is 8 over my old distance from A to P is 12. So my scale factor is 8/12, or 2/3, right? When my scale factor is less than 1, my shape gets smaller, which it did here. Number 19, what are the coordinates of a dilation of 1.5 of ABCD for this quadrilateral? Of course, we're just taking these coordinates and multiplying them by 1.5 to get A prime, B prime, C prime, and D prime. So A prime is 3, 0. B prime is 12, -6. C prime is 6, -9. And D prime is -7.5, -15. Number 20, what are the coordinates of a dilation of 2 about or from point of dilation, center of dilation, X in the triangle XYZ? So I'm taking this shape and I'm dilating it from one of the points on the triangle, point X. So when I do any dilation with a center of dilation at point X prime is going to be the same. It's going to be 1, 1. Point Y prime is going to be double the distances away that Y currently is from X. So to go from the X coordinate of X to the X coordinate of Y, I add 1. So now I'm going to add double that. I'm going to add 2. 1 plus 2 is 3. To go from the Y coordinate of X to the Y coordinate of Y, I add 1. So I'm going to double that, and I'm going to add 2. 1 plus 2 is 3. Z prime, same thing. To go from X to Z, from 1 to 3, I add 2. I'm going to double that, and I'm going to add 4. 1 plus 4 is 5. And then to go from 1 to 0 is -1. I'm going to double that. And so that's -2. So 1 plus -2 is -1. So those are your new coordinates. Number 21, the population density of the city of Wellington is 12,000 people per square mile. The neighboring city, Morrison, is a dilation of Wellington with a scale factor of 1.2. If Morrison has 3/4 of the population of Wellington, what is the population density of Morrison? Let's see, there's a lot to unpack in that one. But the first thing that we should do is we should figure out how big the area of Morrison is. So if we're using square miles here, if I'm thinking of a 1 by 1 square mile for Wellington, I could think of a dilation of the square miles for Morrison. And I could say that the Morrison area per square quote-unquote mile is not going to be 1 mile by 1 mile. It's going to be 1.2 times 1.2, which is 1.44. So Morrison has 1.44 times the area as Wellington. But Morrison also has 3/4 the population of Wellington. So the Morrison population is 3/4 of 12,000, making it 9,000. So the Morrison population is 9,000 people per square mile over 1.44, quote unquote, square miles. So we do 9,000 over 1.44, and we find that we get 6,250 people per square mile. Per square mile. All right. Number 22, what are the coordinates of the center of dilation for the dilation shown? All right, we can do this a few different ways. What I notice here is if I'm going from E prime to E, I go 3 spaces. And I'm going to have to go backwards even further here to find out where that dilation is. But in order to do that, I'm going to need to figure out how big the dilation is. So let's scratch that for now. And let's say, well, I know that ED is 1, but E prime D prime is 2. So this is a dilation that is got a scale factor of 2. If I know that the distance from E prime to E is 3, I'm going to double that distance to get back to my point of the center of dilation. So the distances between that center of dilation, the first point, and the second corresponding point are all going to be in a row, and they're going to be double of one another. For example, if I go from that point to F prime, I can see that the distance from this point to F is up 1 over 5. The distance from F to F prime is up 1 over 5. So that would be a 2 times scale factor. So that coordinate point that we can say is the center of dilation is -1, 3. 23, the images on Henry's digital camera have a width to length ratio of 2 to 3. He wants to make an 8x10 print on one of his photographs. Is this possible? Well, if we wanted to think about the scale factor here, we would have to take something that is 2 to 3, and we want to see if it scales up to an 8x10. Well, if 2 scales up to an 8, that would be multiplied by 4. If 3 scales up to a 10, that's not multiplied by 4. That's multiplied by 3 1/3. So those scale factors are not the same. So I won't be able to do this because those scale factors are not the same between 2 and 8 and 3 and 10. So no, because the scale factor from 2 to 8, it's an arrow there, is different than the scale factor from 3 to 10. So then B says, how can Henry crop an image so that an 8x10 print can be made? So he's taking his original picture. That's not a good enough picture to be a rectangle. Okay. He's taking his original rectangle, which was a 2x3, but he's cutting it. And he needs to change it into an 8x10. So this will be an 8x10. We learned that the larger of the two scale factors here was times 4. So we're going to use that scale factor. We're going to say, all right, what if I just tried to chop this picture in a way that everything could be multiplied by 4 to make it to an 8x10? So this would still be a 2 because 2 times 4 is 8. We're just looking for the number right there that would make that times 4 equal 10. So we can say, all right, well, if we'd use the scale factor backwards and do 10 divided by 4, we get 2.5. So if this picture was 2.5 inches wide, instead of 3 inches wide, that would make this picture able to scale into an 8 by 10. We would just need to cut 1/2 inch off the original picture. Number 25, how far from the screen should the light be placed in order for the shadow of the puppet to be 30 inches tall? Well, it looks like we've got 2 vertical distances and we also have 2 horizontal distances. So let's think about how we could express this. Those vertical distances, I could make a proportion and say that that is the new distance 30 compared to the old distance 25. And then I could make the other side of the proportion and say the new distance from the light to the projector screen. We don't know how big that is. We know that this piece is 2, the distance between 25 and 30, but we don't know the entire distance between the projector or the light and the screen. So that means that I need to use this piece and call it x. So I'm going to say when the height is 30, the length, is x plus 2. Come on, there we go. X plus 2 over when the height is 25. When the height is 25, the length is just x. It's only this distance right here. Then we can cross multiply. We get 30x equals 25 times x plus 2. And we can solve this. 30x equals 25x plus 50 minus 25x. And that is going to give us 5x equals 50 divided by 5. X equals 10. We check our question. How far from the screen should the light be placed in order for the shadow to be 30 inches tall? That was x plus 2. So 10 plus 2 equals 12 feet. All right. Next, copy and complete the table to show the information about dilations centered at the origin. Oh, this is going to be really simple. So we take those pre-image coordinates, multiply them by our scale factor, and get the image coordinates. So we're taking 5, -2, multiplying by 4 to get 20, -8. Here we have 9, 3. What are we multiplying to get to 3, 1? We're multiplying by 1/3. Then we have some number times 1.5 equals -60. So we just have to divide it by 1.5. We get -4.5. No, we don't. We get -4. -4, 0. And then for the last one, -1, 2 times what is -5, 10? Obviously, times 5. And then finally, number 27. A dilation maps ABC to A prime, B prime, C prime. The area of ABC is 13 square units, and the area of A prime, B prime, C prime is 52 square units. What is the scale factor? So we can look at the ratio of the areas, 52 over 13, and that's 4. But we know area is a squared unit. So to find the change in the side lengths, we need to take the squared unit and take the square root of it. So the square root of 4 is 2. So if the area of a shape increases by 4, or 4 times, the side lengths of the shape will only be 2 times longer. Because if we go 2 times longer one direction and 2 times longer the other direction, that area gets 4 times as big. So 2 is the answer to the question. All right, if you've got any questions on this worksheet, feel free to ask me in class, and have a wonderful day.